The next one is give condensed and bond line structural formulas and identify the functional group present in it. So now let us start with the first one is 2, 2, 4 trimethyl pentane. Okay. Now this is a question given to us. Now we need to write down the condensed formula. So in order to write down the condensed formula, let us first write down the structural formula. So pentane means 1, 2, 3, 4, 5. Then on the second position, we have a CH3 group 2 times. Then on the fourth position, CH3 group. Balance it with hydrogen. This is CH2. This is CH. This is CH3. Clear? So this is the first question. Now, after this, I'm going to write down the condensed formula. So in order to write down the condensed formula, whatever it is same or repeated, that we are going to write it down in the bracket. Clear? So CH3 we have here, this is CH3. After the CH3, I'm going to put this carbon. And on this carbon, 2 CH3. So write down CH3 2 times in the bracket. Then this carbon, CH2. Then we have CH. And next to the CH, we have CH3. And then lastly, we have CH3. So basically, whatever is in the chain, we write it down that. And the one which is present at the top and below the carbon atom, we are going to write it down in the bracket. Okay, never put that in the chain. Now, this particular structure, I can also write it down in a different way. Okay. Now, since we have this carbon atom, so this carbon atom, it is connected to 3-methyl group. Okay, so instead of this thing, I can write it down carbon and it has a CH3 group 3 times, right? So I can write it down in this way. Then after this carbon, okay, I'm talking about this carbon. After this, there is CH2 group. This group I'm going to write down now. So it is CH2. Then next to CH, we have a CH and then again CH3 2 times. Clear? So what I have done is this CH3 also I have written it in bracket because this CH3 is also present on this carbon. Right? Okay, so this is the condensed formula I have written. Now let us quickly write down the bond line structure. Now how we are going to proceed with the bond line structure? Now let us start with this carbon. This is 1, 2, 3, 4 and 5. So 1, 2, 3, 4 and 5. And on the second position, I have a 2-methyl group. So like this I am going to draw. Okay. You can also write down one top and one below. Okay. So both are correct. So this is the bond line formula. Let us quickly proceed with the B question. B question is 2-hydroxy 1, 2, 3 propane tricarboxylic acid. Now looking at the question, do not panic. Okay. No matter how big the question is, okay, or how complicated the structure is, we are going to simply break it down, okay, in parts. Now let us first start with, now what is the word root? Okay, whenever you have a complex naming or a very big naming, we are going to start with the word root. Now very first thing is, we have this propane group, okay, prop means 3 carbon. So I'm going to draw first 1, 2 and 3 carbon. Okay, now this part is done. ANE means, this ANE stands for carbon-carbon single bond. So I have put single bond. After this, we are going to now draw the substituents present. On the second position, we have hydroxy. So this is OH group. On the first position, on the second position, and on the third position, we have a COOH. Okay, this is COOH. Again, COOH. Clear? Now, there is a space over here. So, instead of writing it over here, I can write down next to this carbon. Same way, since there is a space, I can write it down here. COOH. Clear? Now, let us quickly write down the condensed formula for the same. Now, the condensed formula is again of the similar type. I'm going to put COOH. Then next to this, okay, I'm going to put carbon. because this carbon, on this carbon COH group is present, right? So I'm going to put it in bracket. Then we have the next one is C, okay? And on this C, we have OH group as well as COOH. Clear? And then the next one is CH2, okay? So I'm going to put dot CH2, and then on this CH2 group, there is again what? There is again COOH group. So I'm going to put it in bracket. So this is how we are going to write down the condensed formula. Okay. And then finally, I need to now draw the bond line. So for bond line, again, it is very simple. So you put 1, 2, and 3 carbon. On the first one, there is COOH. So C, this is C. Okay. Then on the C, double bond O, and then OH. Clear? Same way, this is C, double bond O, and OH. And then on the second position, we have OH group. Clear? At the same time, we also have on this carbon, the second carbon, we have a COOH. Okay. So this is C. Clear? This is C, double bond O, and then we have OH like this. Okay. I hope the concept is clear to you. Let us now proceed with the last one. The last one is hexane diol. Okay. Now again, very simple. I'm going to draw 1, 2, 3, 4, 5, and 6. Finally, over here in the terminal, I can see diol. Ol means what? There is what? Presence of CHO group. And di means 2 CHO group. Hex means 6 carbon. And AN means what? It is carbon-carbon single bond. Clear? So everything I have split it up. 6 carbon I have put. Then 2 CHO group, it will be present at the terminal. Okay, because we know that CHO, it is always present at the terminal. So this is CHO, and then here also I'm going to put CHO. Clear? And then finally, I'm going to balance it with hydrogen. So here it is CH2, 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 and CH2. Clear? So CHO is present at the terminal. Between this CHO group, we have CH2 group 4 times, and then again CHO. Okay. And lastly, I'm going to draw now the bond line structure. The bond line structure is, I'm going to start from here. This is 1 carbon, 2, 3, 4, 5, and 6. Okay. Then the first carbon is nothing but CHO. So I can put it like this, C double bond O. That's it. Do not put here 1 bond for hydrogen. Okay. If you're putting 1 bond means there is presence of 1 hydrogen. So again, this is double bond O, and then of course there is hydrogen. The total 1, 2, 3, 4, 5. Okay. Total. Okay. Now for the bond line, this is 1 carbon, 2 carbon, 3, 4, 5, and 6. Clear? So now this carbon, the first carbon, it is bonded to C double bond OH. So this is C double bond O. Again, this 6th carbon, it is bonded to C double bond OH. Do not put here and then put or leave as it like this one. Do not put a bond over here. Because if you're putting a bond, that means there is a presence of carbon. Okay, so for hydrogen, no need to show bond. Clear? It is understood that there is a presence of hydrogen. Okay, I hope the concept is clear to you. Quickly, you can take a screenshot of this. Still, if you have any difficulty, you can write down in the comment box. Thank you.